Hello बच्चों, let's read the question. A function f is defined as follows. fx is equal to 1 for values of x in the interval minus infinity to 0. Then it is 1 plus mod of sin x for x in the interval 0 to pi by 2. Then it is 2 plus x minus pi by 2 the whole square for x in the interval pi by 2 to positive infinity. Discuss the continuity and differentiability at x equals 0 and x equals pi by 2. Solution शुरू करने से पहले let's note down the key concepts for this problem. So the first key concept is the definition for continuity of a function at a point. That is, a function fx is said to be continuous at x equals a if limit as x goes to a of fx is equal to f of a. And the second key concept is the definition of differentiability of a function at a point, say x equal a. So fx is said to be differentiable at a point, say x equals a, if limit as x goes to a of fx minus fa divided by x minus a exists. And if this limit exists, then the derivative of f at a will be equal to the value of limit as x goes to a of fx minus fa divided by x minus a. अब इन दो की कॉन्सेप्ट्स की हेल्प से let's now start our solution. Now in the question we have given the function's definition as fx is 1 for values of x in the interval minus infinity to 0. Then the definition is 1 plus mod of sin x when x lies between 0 and pi by 2. Further, the definition is 2 plus x minus pi by 2 the whole square for values of x in the interval pi by 2 to positive infinity. Lekin as x is in the interval 0 to pi by 2 and इस interval में we know that the sin x function is always positive. तो अगर mod function के अंदर हम कोई positive value डालेंगे तो जो final value मिलेगी वो वही value वापस आ जाएगी. So fx can be rewritten as 1 for values of x in the interval minus infinity to 0, then 1 plus sin x for x in the interval 0 to pi by 2, then 2 plus x minus pi by 2 the whole square for x in the interval pi by 2 to positive infinity. Now in the question we have been asked to check the continuity and differentiability at points x equals 0 and x equals pi by 2. So let's check continuity. So first, continuity. So for point x equals 0, तो 0 पे चेक करेंगे. Let's get the limit as x goes to 0 minus. अब 0 के लेफ्ट में फंक्शन डिफाइंड इज कांस्टेंट 1. सो यहाँ पर आ जाएगा लिमिट एज x गोज टू 0 माइनस ऑफ fx. क्या आ जाएगा? लिमिट एज x गोज टू 0 माइनस ऑफ द फंक्शन इज 1. लिमिट क्या आ जाएगा? 1. अब राइट हैंड लिमिट देख लेंगे एज x गोज टू 0 प्लस ऑफ fx. अब 0 के राइट हैंड साइड में द डेफिनेशन ऑफ फंक्शन इज 1 प्लस साइन x. So limit as x goes to 0 plus of 1 plus sin x, and as x goes to 0, sin x goes to 0, तो लिमिटिंग वैल्यू क्या आ जाएगी 1. So limits are equal, and so therefore limit as x goes to 0 of fx is equal to 1. But लेकिन f of 0 की वैल्यू is equal to, see, at 0 function defined is 1 plus sin x. So substitute करेंगे तो क्या आ जाएगा 1 plus sin 0, that is equal to 1, and so this is equal to f of 0, and so therefore fx is continuous at x equals 0. अब let's check the continuity at for x equals pi by 2. अब pi by 2 पे continuity चेक कर लेंगे. वो कैसे? Let's get the left hand limit and right hand limit. So limit as x goes to pi by 2 minus of fx equal to limit as x goes to pi by 2 minus of. अब pi by 2 के left में definition of function is 1 plus sin x. So we have 1 plus sin x, and limiting value evaluate करेंगे तो आ जाएगा 1 plus sin pi by 2, and that is 1 plus 1, and the overall limiting value is 2. Now let's get the right hand limit. So limit as x goes to pi by 2 plus of fx equal to limit as x goes to pi by 2 plus of. अब pi by 2 के right में the definition of the function is 2 plus x minus pi by 2 the whole square. यहाँ आ जाएगा 2 plus x minus pi by 2 the whole square, and यहाँ पर अगर लिमिट लगा लेंगे तो आ जाएगा 2 plus 0, and that is 2. Again we have equal limits, so therefore limit as x goes to pi by 2 of fx is equal to 2, and at 2 the definition of the function is 2 plus x minus pi by 2 the whole square, and f of 2 is therefore equal to 2. So we have limit equal to the functional value, and so therefore we can say fx is continuous at x equals pi by 2. Now let's check differentiability at x equals 0 and x equals pi by 2. So second point, differentiability. अब differentiability check करेंगे at, so we have for point x equals 0, and for that let's check left hand derivative, and that is limit as x goes to 0 minus of fx minus f of 0 divided by x minus 0. Now 0 के left में the definition of the function is 1, and at 0 the value of the function is 1. So therefore substitute कर लेंगे तो आ जाएगा limit as x goes to 0 minus of 1 minus 1 divided by x, and that is equal to 0. Now let's get the right hand limit. यहाँ पर आ जाएगा limit as x goes to 0 plus of fx minus f of 0 divided by x minus 0. अब limit as x goes to 0 plus of, अब 0 के right hand side में the definition of function is 1 plus sin x, and at 0 the value is 1. So substitute कर लेंगे, आ जाएगा 1 plus sin x minus 1 divided by x, and this gives us limit as x goes to 0 plus of sin x by x, and इस लिमिट की वैल्यू आती है 1, and so therefore लिमिट्स अनइक्वल है. इस वजह से हम क्या बोलेंगे, लिमिट एज x गोज टू 0 ऑफ fx माइनस f of 0 डिवाइडेड बाय x माइनस 0 डज नॉट एग्जिस्ट, एंड ये लिमिट एग्जिस्ट नहीं कर रही. इस वजह से हम क्या बोलेंगे, therefore fx is not differentiable at x equals 0. And now lastly, let's check differentiability at x equals pi by 2. For x equals pi by 2. अब differentiability check करने के लिए let's check the left hand limit and right hand limit, that is left hand derivative and the right hand derivative. So limit as x goes to pi by 2 minus of fx minus f of pi by 2 divided by x minus pi by 2. So यहाँ क्या आ जाएगा, pi by 2 के left में the definition is 1 plus sin x, and at pi by 2 the value of the function is, so at pi by 2 the value of the function is 2, and so therefore substitute कर लेंगे, आ जाएगा limit as x goes to pi by 2 minus of, यहाँ आ जाएगा 1 plus sin x minus 2 divided by x minus pi by 2. अब इसे सिंप्लीफाई कर लेंगे, this limit is limit as x goes to pi by 2 minus of, here we have sin x minus 1 divided by x minus pi by 2. Now this limit is of the form, so as x goes to pi by 2 minus sin x goes to 1, so this is 1 minus 1 0, and denominator में भी pi by 2 पे जाएगा जब x, denominator will also go to 0, so this limit is of the form 0 by 0 form. So let's first note down the statement of L'Hopital's rule. So L'Hopital's rule says that if limit as x goes to a point a of fx is equal to limit as x goes to a of gx is equal to 0, then limit as x goes to a of fx by gx is equal to limit as x goes to a of f dash x divided by g dash x, and यहाँ पर अभी L'Hopital's rule अप्लाई कर लेंगे. So therefore we have limit as x goes to pi by 2 minus of fx minus f of pi by 2 divided by x minus pi by 2 equal to limit as x goes to pi by 2 minus of sin x minus 1 divided by x minus pi by 2. अब L'Hopital's rule अप्लाई कर लेंगे, so यहाँ आ जाएगा न्यूमरेटर का डेरिवेटिव cos x and डिनोमिनेटर का 1, so this is limit as x goes to pi by 2 minus of cos x, and यहाँ पर as x goes to pi by 2 minus cos x goes to 0, so the limiting value is 0. Now let's check the right hand derivative. So limit as x goes to pi by 2 plus of fx minus f of pi by 2 divided by x minus pi by 2. So for this is equal to, अब pi by 2 के right hand side पे the definition of the function is 2 plus x minus pi by 2 the whole square, so substitute कर लेंगे, so this is equal to limit as x goes to pi by 2 plus of 2 plus, here we have x minus pi by 2 the whole square minus 2 divided by x minus pi by 2. Simplify कर लेंगे, so this is limit as x goes to pi by 2 plus of 2 to cancel, and यहाँ पर आ जाएगा x minus pi by 2 the whole square divided by x minus pi by 2, and now we can cancel this out because x is going to pi by 2 but not equal to pi by 2, and this is equal to limit as x goes to pi by 2 plus of x minus pi by 2, and यहाँ पर वैल्यू आ जाएगी 0. एंड नाउ सो देयरफॉर अब लेफ्ट हैंड लिमिट एंड राइट हैंड लिमिट दोनों सेम है, सो क्या आ जाएगा, लिमिट एस एक्स गोज टू पाई बाई टू ऑफ एफ एक्स माइनस एफ ऑफ पाई बाई टू divided by x minus pi by 2 equal to 0. And so as this limit is existing, therefore we can say that function fx is differentiable at x equals pi by 2. So therefore this is our final answer. I hope you understood it well. Best of luck and thank you.